So in this video, I want to look at Group A and Group B separately and see what things look like there. So let's try to compute the correct classification rate for Group A. So I'll call it like CCRA. So this would be the number of people who we got correct from Group A divided by the total number of people in Group A. So the total number is 100. Just because we have like 60 high risk, 40 low risk, so 100 in total. So how many of those do we get correct for the 60 and the 40? So for 60, we get 80% correct. So 80% of 60 is 48. So we can say 48 we got correct. And then out of the 40, we get 90% correct. So 90% of 40 is 35. So we got, 36. So we got 36 correct. So that would be, 48 plus 36, that is 84% of people out of the 100 in Group A, we correctly predicted whether they will or will not be arrested. What about Group B? So we'll say the correct classification rate for Group B. So out of the 50 for whom we said will be rearrested, 80% of them will. So 20% of them will not be. So 80% of 50, that would be 40. So 40 people we got correct out of those 50 because we said they're all going to be arrested, and 40% of them, 40 people are going to be arrested out of those. And then out of those 50 for whom we said will not be arrested, there is a 10% chance that they will. 10% of 50 is 5. So we got 45% correct. So 45. And then there is 100 people in Group B, just like in Group A, different 100 people. So that would be 85. So we got different correct classification rates for Group A and Group B. And the reason for that is that the initial split of high risk versus low risk was somewhat different in Group A and Group B. So if the discrepancy were larger in terms of the composition of Group A and Group B, we'd get even more different correct classification rates. So you'll recall that in the previous video, we actually got 84.5 and we just rounded it to 85. But here we see, oh, actually, like the correct classification rates are different. So that though does not mean, so that means that the classification that the accuracy parity is not satisfied because we're more accurate for Group B than for Group A, just slightly. That does not mean that other kind of fairness criteria are not satisfied. So in particular, let's look at how much of the time are we right when we say that a person is going to be arrested. Well, both for Group A and Group B, we're right exactly 80% of the time, right? So what we're looking at is basically the positive predictive value, right? So the positive predicted value for A, that's going to be the total number of people about whom we are right that when we say that they're going to be arrested, divided by the total number of people who we say are going to be arrested. So we say that about 60 people, and we are right about 0.8 times 60 people. And for B, well, we say that about 50 people, and we are right about 80% of them as well. So that, of course, is going to be 80%, and that is going to be 80%. So the positive predictive value here is the same. Positive predictive value parity is therefore satisfied, even though accuracy parity is not satisfied. And here you kind of see that there's no easy way around this. So if you change the accuracy, well, you'll mess with the PPV and vice versa. So we'll see exactly how in the next video.